In this video, I'm going to show you how I use a bead string just like this to teach quotition division. And so while in this video, I want to show you how I use a bead string to cover quotition division, we need to understand both. And I totally understand if you get a bit confused by these terms because it does get a bit tricky. And so the difference really comes down to how we're conceptualizing this number 6. So in partition division, that 6 becomes the number of groups. So we're saying, well, we've got 30. And if we shared 30 equally between 6 groups, how many would be in each group? So the number that would go here would be the amount in each group, the equal amount in each group. So when we're thinking about partition division, we're really thinking about equal shares. We're thinking 30 shared between 6. And for me to help differentiate between these two different ways, I like to see it written as a multiplication question. So with partition division, we're saying we've got 6 watts, so 6 times watt is going to equal 30. So notice again, the emphasis is on having 6 groups. 6 groups of watt is going to equal 30. All right, so now let's have a think about quotition division. So this time, instead of thinking of the 6s as the 6 groups and how many are in each group, we're going to give each group 6. And we're going to say, if I have 30, how many 6s are there in 30? So how many equal groups of 6 are there in 30? So now I'm saying that my group is 6, and I'm trying to work out how many of those groups I will need to get to 30. And so you can see the difference here when I write that as multiplication. This time I'm saying how many groups of 6 are there in 30? And we both know that these will end up with the same answer. It's just the way we're thinking about it. And so while students need to understand both, our bead strings can be super handy for explaining quotition division. All right, so now let's solve our problem using our bead string. So 30 divided by 6, or how many 6s are there in 30? Let's make 30, knowing that I've got 3 10s. And so now I'm going to see how many 6s I can make. 1, 2, 3, 4, 5. So straight away, I can see that there are 5 6s in 30. Now, the cool part about this is that you can see how those 6s are being split up over the 10s. So for example, here, after I grab my first 6, my second 6, you can see how we've had to split our second 6 into a 4 and a 2 to get to 12. Now, let's do another one. Let's say I had 25 divided by 5. And so again, I'm not thinking of trying to split this into 5 equal groups, but instead I'm trying to think how many 5s are there in 25. And so again, I might go 1, 2, 3, 4, 5. There's 5 5s in 25. Now, the really cool thing about teaching quotition division in this way is that once students start to get familiar with it, they can start building up from known facts. And they don't always necessarily need to break the whole thing apart. So for example, here, they might not know how many 5s are in 35, but they may already know that 6 times 5 is 30. Because they might have worked out by this point that for every 10, there's going to be 2 5s. So it would be just 2, 4, 6 5s. And then they've just got to go, oh, well, if I know 6 times 5 is 30, then one more 5, here, altogether, there must be 7 5s. So I'll demonstrate that with this next example here. We've got 48 divided by 4, or again, how many 4s in 48? Now, I might not know all my times tables, but hopefully I'm pretty good at my times 10 and times 5. So maybe I could use one of those as a bit of a benchmark. And if I did that, I can hone in on this answer really quickly. So for example, I would hopefully know that 10 4s are 40. So without even needing to split this up, I know that there's going to be 10 4s in there. And so then I just have to work out, well, how many more 4s are there in 48? And knowing that I've got 8 left here, I can split that up into an extra 2 4s. So I've got my 10 4s from my 40, 11 4s, 12 4s. There are 12 4s in 48. And so the goal with teaching quotition division in this way is not to simply just go through the motions and every time they go, all right, how many 4s in 48? I'm going to make 4 then another 4, and then another 4, and then another 4, and then blindly count them all together. It's about using what we know in that place value structure, using the known facts that we can know to build on to make predictions and hone in and hopefully develop our number sense through doing this, so that down the track we can move the concrete model away and still have this as a strategy that we can then do mentally. So there you go, another use for your bead string. But division is one of those tricky things that it is hard to teach and it is a bit nuanced. So if you do happen to give this a go, let me know how it goes. I'd love to hear about it. All right, your turn. Go math it up.